I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I'll be talking to Matt DeBruine and Ben Hoxie of Eaton about the company's dynamic machine control technology. So thank you, gentlemen, for joining me today. I appreciate it. So if you could maybe first kind of provide an overview of Eaton's dynamic machine control technologies, or what it entails and the benefits it offers?
Yeah, Sarah, thanks for the question. I would ask that we talk about dynamic machine control as really a way of thinking and less a product or a component. It's really Eaton's approach to the intelligent machine movement. It's focused around taking components on a machine and leveraging and working together through software, through the information that's being developed and generated on a machine every second, and making better decisions about what the machine needs at that moment. It's really focused around better solving our customers' needs in regards to efficiency, simplifying and improving productivity, focused on safety. It's really an approach to how we solve challenges on the machine, and do that in a more quick and efficient process through software and those types of things.
Mm-hmm. Okay. And so I guess what are some of the technologies or aspects that go into this dynamic machine control?
This is really how we look at all of the pieces coming together as a system, whether it's sensing and intelligence, whether it's hydraulic components, electronic components, electrical components. It's really reimagining the machine and the machine builder's challenge with a whole new, different kind of approach.
Mm-hmm. Okay.
And so what that then yields us is quite a change in the way the machine behaves. And maybe it's a productivity improvement, a performance improvement, but rather than looking at each individual piece, how do they all come together to solve the machine builder challenge?
Mm-hmm. Okay. And so maybe then can you go into a little bit, what are maybe some of the vehicle or system improvements that can come about from, say, an OEM integrating this technology into a piece of equipment?
Yeah, that's going to be best answered in the context of the machine. And it's really, what is the user trying to do with the machine? Is it be more productive? Is it get more work done in a day, consume less energy, be more precise? And so one example we use of this is the boom stability control technology we've talked about and folks can find from Eaton. Deployed that on very large booms, whether they be concrete pumpers, 50, 60 meter long booms, rescue ladders for fire trucks that are rescuing people from high-rise towers, those kinds of things. So that's built upon our CMA valve, but also incorporating other Eaton technologies, whether it be cartridge valves or pumps or controllers, sensors, software. And so what that then yields is a significant reduction in the oscillation, the bouncing of the boom, demonstrated 75% peak-to-peak reduction and a 90% improvement in the settling time. If you think about how that then plays out for a representative concrete pumper, it's easier to drive the machine. The learning curve isn't as steep. They can get more work done in a day. They can be in and out of the job site faster, those kinds of things. On a fire truck, maybe that means they can be minutes faster in terms of getting that boom up and close to the building and rescuing people. Obviously, in a rescue situation, time is of the essence.
Mm-hmm.
Yeah, I was actually on a walk yesterday, and I was watching them move drywall from a flatbed truck to the upper window in a home so they could install it. And when they used the crane arm to hook the drywall and move it over, that movement started to get that boom to swing significantly side to side. And what they do is they move that arm down and they hit the drywall against the side of the machine to get it to stop, damaging the drywall a little bit, and then move the arm up into the second story of the home. And so, like Ben said, that reduction in oscillation through dynamic machine control really makes that problem non-existent anymore.
Mm-hmm.
Okay.
Great example, yeah.
And is this a technology that would you would integrate at the OEM level with an equipment manufacturer? Is it more of an aftermarket solution? Is it both?
Yeah, the boom stability control really is integrated at the OEM level. We have some other options that we're working with aftermarket partners that could be done afterwards. Things like GPS guidance on tractors for precision farming. Driver augmentation things are sometimes a little easier to do aftermarket. Boom stability specifically is pretty deeply integrated into the machine. That's better done at an OEM level.
Okay. Okay. And so then would Eaton work directly with the OEM to integrate the technology?
Yeah, very much so. I mean, it is a very collaborative effort where we're beginning with engineer to engineer discussions, looking at the challenges, looking at the concerns and the customer needs of our customers, of these OEMs, and diving into the specific challenges, and then building it from the ground floor up.
Okay. All right. And so are there maybe other off-highway heavy-duty equipment applications that this would be well suited for that we haven't kind of covered so far?
I would, like I said in the beginning, right, I would encourage you to think about it as really a way to view an intelligent machine. And so it really can get used across the spectrum of machines. We talk about boom stability control and some of the tractor work as some of our most recent examples, but I would view any machine that's leveraging electrohydraulics, that's becoming more sophisticated, that's generating and developing more data, leveraging software and controls throughout the machine as really the focal points. We have examples, at Eaton where we've looked at wheel loaders, where we're looking at skid steers, and it really can get used across the industry. And those are mobile examples, but very much appropriate in the industrial space as well, as they're surrounded by information and technology and Wi-Fi, and that ability to connect products becomes even easier.
Okay. All right. And so is it just the integration of software and sensors that would make it well suited for especially those, as you said, sort of the electromobility kinds of applications, or what maybe aspects of the technology helps it suit those?
Yeah, I can take that one. Really, we start from what's the machine challenge that the customer is having. Many of these things are best solved with software. It doesn't have to be that way, but when we think about the wide variety of ways in which machines get used, software becomes much more adaptable in the moment, and a hit of a button or a flick of a switch can change that machine behavior. And maybe if I'm moving drywall that day versus roof shingles, maybe that same crane has a different feel or a different operating mode, tying back to the example Matt shared before. Or on a concrete pumper, maybe I just want to hit a button and have this long, complex, large boom auto collapse and auto store on the machine and free up the operator to be doing some other things at that time. So those kinds of examples are very much built on sensing and software and intelligence being deeply integrated into the machine and into the product. And so that is really the key technology that opens it up and unlocks it, but it's really a different way of thinking about it, and how do these different pieces come together to help solve the machine challenge.
Okay. All right. And so do you guys kind of see, is this sort of the way of the future for hydraulic systems, or just other systems within a heavy piece of equipment, and sort of the integration of all the various types of technologies to help with the improved efficiencies?
I very much see this as the way of the future, and it goes beyond the typical systems of today. As machines become more electrified and there's more communication across the whole spectrum of the machine, the intelligent machine control will just continue to evolve and become even more important. Machines will continue to evolve. They will continue to become more intelligent and more sophisticated, and our ability to intertwine the hydraulics and the electrics on the machine is the key to solving OEM and customer challenges more quickly and more efficiently.
Yeah, an example of that is we're working with a number of customers who are deploying more and more battery operated vehicles, and there isn't really a good alternative to hydraulics for power density and control as it pertains to linear motion and boom and digging type structures. And so the big challenge with batteries is how do you get them to last long enough to be effective for the machine? And part of that answer is how do you design the hydraulic system? The levels of losses, the efficiency, the control can very quickly come back and extend the battery life 30, 40, 50% just by a better design of the hydraulic system and understanding how the electric technology and the hydraulic technology work together. Mm-hmm. So very much focus point for us going forward.
Mm-hmm. Okay. And that's something then the dynamic machine control technology would be able to help with?
Yeah. Yes, very much. How that hydraulic system comes together with the electric system with the batteries is all exactly what we would describe as dynamic control BMC solution.
Okay. All right. Could you maybe are you able to go into a little bit how that might integrate or with a battery operated vehicle system and kind of overview that a little bit?
One of the things that I think about a lot are, when you get into, pumps and motors and really power on demand. When do you need power and when do you not? How are you using controls? And like Ben said, right, it gets into, these batteries. How do you conserve battery energy to last, to make the machine last longer? And so things that we can do to control our pumps and motors and make more intelligent decisions about what to use and when and how much, that backbone, provides a more efficient machine that will increase the battery life.
Those are all the questions I had for now. Did you guys have anything else you would like to add about the technology? I think our audience should know.
Just that we're here to help them, right? If they've got machine challenges, reach out to their local Eaton rep, find us on the web or your local folks, and we're here to help. Let us know what we can do.
Well, thank you guys very much for speaking with me today about the Eaton's dynamic machine control technology. I really appreciate it.
Our pleasure.
Yeah, thanks for having us, Sarah. We appreciate it.